Thank you. Hello, everyone. Thank you so much for the introduction. I'm so glad to see you all here. Are we good with volume? Or do you want me to speak louder? OK, got it. Cool. Thank you, everyone. I'm so glad to see you all here. As mentioned, my name is Andrew Eck. I'm a principal engineer at Launch Scout. We build mostly web applications, mostly with Elixir, and I get to work with our apprentice program. So if you'd like to talk more about any of those things, please come talk to me later. But before we get into any of those things, I should tell you a couple of things about myself as a slightly long-winded introduction. The first is that I'm a big fan of my family. The second is that I'm a big fan of the American bison. And of course, going around and taking pictures of the American bison with said family. And so as a contrived lead-in to this, I promise none of this actually happened, but one can imagine that we were driving through the prairie and we happen across a team of veterinarians who have an Elixir application, a Phoenix application specifically, and in the style of every running application ever, they've got a bunch of reports that they want to run. A bunch of reports. They want to know what bison are due for veterinary appointments, and what ones have not yet scheduled their veterinary appointments, and what ones are in perfectly good standing, and all of that, which gives us a little bit of familiar code. And this is, again, a contrived example. But every piece of legacy code that I've ever worked in, and as a consultant, I get to switch code bases every 3 to 6 months. Every piece of legacy code that I have ever worked in has involved some reporting component with a bunch of methods that return basically the same resource with slight variations. And I see some of this like very knowing nodding in the audience. So here's one. For example, this bison needs to, or this is a list of bison who need to schedule an appointment. By definition, they have an appointment at some point in the past. They've not yet scheduled their follow-up. And so we write code that looks like this with a repo.all and a bunch of Ecto.Queries and things like this. And it's fine. It's fine. And of course, we might want to find just the ones who are overdue. The code here, with this appointment subquery, and with this bison repo and all that, is basically the same as the code above, modulo a couple of lines. Or maybe we want to be able to filter it down to just a single prairie, in which case we have this code, which is basically the same as the code above, except for this one little line. We're filtering by the prairie ID. Or perhaps we want to go by state. All the bison in Nebraska, all the bison in California, all the bison wherever. This is exactly the same as the previous section, except these 2 lines. And this is every single code base that I've ever come into has had some reporting component that looks more or less like this. So in some cases, several thousand lines with a couple of variations on the same set of data. And what that then means is that the cost of change for any of those things goes up in complexity. And also, it means that all the developers who have only ever used an ORM, perhaps the Rails developers who came over, they're used to Active Record, now they're in Ecto, and they're thinking, I got to do a little bit of SQL, but not that much, it's OK. But oh no, we got SQL. We have subqueries, we have joins, we have left joins, we have all sorts of exciting things that ordinarily a lot of our developers have not yet really had to work with. So not only are folks coming in and mucking with things that look a lot like SQL, they're also mucking with a bunch of things that are nearly identical but have some subtle differences, some subtle implementation differences, and it all looks like SQL. And when we need to change things, perhaps we only want the bison who are currently alive. Perhaps we only want the bison who are not on vacation. Perhaps we only want the bison who have not moved to Arizona to start playing pickleball. Those are things that we might be curious about. We have to go and change that in every single place. So what this talk then is a very practical, tactical approach to refactoring, mostly in your reporting layer and mostly your Ecto queries, in a way that eventually starts looking just a little bit nicer. And so the goal is a thing like this, where as we're working down, we're filtering by the state code. We are getting an aggregate. An aggregate is, if you're into the domain-driven design, it's a resource plus some graph of other resources attached to it. And we're getting all of them. So something like this, most, even like a junior developer, can come in and probably at least get the human meaning of this, even if they are not comfortable yet with the the subqueries and the materialized views and all the other things that we might be doing if we're really into SQL. And then they can work with it, which is exciting. So how do we get there? We write code. A place that I like to start, and I'm going to open up a terminal as well. I'll typically organize these things as a series of composable queries. And a composable query, this notion the first time I came across this was in Bruce Tate's and James E. Gray's Designing Systems with OTP book. They've got a really great section about composing pipelinable code, which is exactly what we've got here, where the idea is that you have some token or some accumulator that you're passing down through a series of pipelined together functions, and at the end you have a thing. You have an accumulator, you have a token, whatever you might want to call it. And what this ends up giving us is code that's pretty fun to work with. So we can work with it just a little bit. I will typically, what is often the case, especially if we're talking about users, is you end up with like user as the sort of God object that's attached to everything. Everything is associated to a user or an organization in most code bases. But in actuality, we often will have different views of these. In this case, we've got just the bison queries that matter for our veterinarians, who again are trying to find like what bison are due for a physical, what bison are due for their shots, what bison have not been in for a while because they're being real Midwestern about it. And in the Midwest, we only go to the doctor if we think we might die. And even then, that is just our pattern. That's how we live. Poorly, very poorly. So I've also got mixed test watch running, so a very tiny plug, side note for it. Every time we save, it'll run, and then a little terminal window will show up right at the top, which is, well, it should. Must be on Do Not Disturb. That's fine. So here's an example. Got a base query. We could call a repo.all with this. This is from bison and bison. And I guess to back up, the key to this, so we've seen things like a repo.all, and then we pass it a struct name, right? So query.bison. We've seen things like this. We happen to have, I think, 7 bison in the database. Bryce and Brianna and Balthazar and Bellerophon and Belinda. We've seen things like this, where you're passing in the name of an ecto schema, but you don't have to do this. We could also do something like this, right? Query equals, oops, I need to import ecto query. And I could do something like this, query equals from bison in bison. And I can do a repo.all query. I can also do something like from bison in query. Remember, query is from bison in bison, where bison.age is greater than 4. And I can pass that to a repo.all. After wrapping it in parentheses. And so what this means then is that we can build a query, and then we can select from that query, and then we can select further from that query, and then we can select further from that query. We don't need to just be passing things in. We can build these things together, which in turn gives us the ability to compose these like token-style reducer pipeline chains, which is really exciting. So let's play with one just a little bit. We've got this age at most, age at least and age at most. We can even put those things together. So something like an age between, where we take a queryable, pass it to the next one, pass it to the next one. That doesn't do anything for us for our veterinary bits. We're going to have to go back and start decomposing this, but it feels useful to me to set up a somewhat trivial early bit. Let's delete all of this. Pure chaos mode. We're deleting code. OK. Let's start with this overdue for appointment 0. So to put this in human language, any bison that has not had an appointment in at least 6 months is overdue for the next one. You got to come back in for the yearly physical. Your insurance pays for it. That's great. You should do it. And we can start just first teasing it apart. And then after we have had the chance to tease it apart a little bit, we can pull it into functions. So we can even do something like query equals b in bison. We're just going to pull this little bit out. We'll left join our last appointment and our subquery, our appointment subquery helps to spell join correctly. Then we'll get our on our last appointment, bison ID. Okay. Get rid of this. Whoops. This should still work. We're almost composing together. We're not quite. We're teasing it apart just a little bit. Previously, this section was in here. Broken it just a tiny bit. Let's watch it run. What's going on here? Because we don't have the named binding. We can also do something like this. Bison, last appointment and query. And so a named binding, that's this as right here. That gives you a binding that you can carry forward through, through your composed queries. Let's work with that. Should pass. This needs. What was that? I'm sorry, Doug? Yes, it is. Yes. Awesome. There we go. Off we go. Exciting stuff. And so we can pull this out just a little bit further. We're going to reorganize this in just a second. And so with this nil last appointment, now we can do something like query with nil last appointment. Bison report at all. This should still work. We'll find out for sure, yeah. This is the start. This is where we can start getting with this. We can pull this piece out. And we're breaking some conventions by not organizing things quite yet. We'll clean this up. We can say, I think instead of by, let's call this by nil last appointment. A convention that I've found useful is to use by to indicate a where clause, then with to indicate a join. Now we can pull out this appointment subquery. And then off we go. This should also work. Nope, not quite. Because just the spell again. Okay. We're passing the queryable in. We're still grabbing it. We're still passing. So what we've been able to do is pull quite a bit out. It's kind of exciting. And if we compare, down to the end. If we compare, we've cleaned things up a little bit. A little bit. It's kind of pleasant. We can do the same thing with the next one. The only difference between this one and the previous one is that we have this, we're filtering by prairie ID. So, deleting a bunch of code. It's my favorite kind of pull request. More red than green is always going to make me happier. Then we can say, in prairie, okay. In prairie doesn't exist yet. We'll clean this up a little bit further. We need a queryable. The first argument, typically when you're composing these chains, is your accumulator or your token. Every argument after that is whatever you might need. So, from bison in queryable, where bison.prairieid equals in the ID. We'll save this. We're still passing. We've cleaned up a bunch of code. So if we think about, here we can scroll this down just a little bit. If we think about the top section versus the bit right below, the one on top carries semantic meaning. We're not bogged down in the implementation details, and typically we'll want to pick a single level of abstraction. This comes from clean code, and then Bruce Tate and James Gray mentioned that as well. If the implementation changes out from underneath, we're okay. We change it in a place, and the rest of it should follow, assuming we've composed things correctly, and assuming that we have tests checking our validity and our verifiability and all of those things. So it gets pretty exciting. There's some fun bits here that we can go even further. One bit, I'd like to join this, I'd like to pay attention to this just a tiny bit more. With prairie, here, where are we? Let's go by state code. Okay, every prairie has a state code, just like NE or CA, WI, wherever a bison might live. And this one, we're doing a join. With the way that things work right now, like that join is okay. We're okay to join here. But with those named bindings, we're kind of limited just a little bit in how many times we can join. That doesn't matter as much here, because this is a contrived example. But if we find that we want to join across the same association or across the same table multiple times, things get weird. So we have those named bindings to carry through. And we can see this already. Actually, well, this last appointment does it. And so this with last appointment, we're joining. Things get a little odd if we do 2 with last appointments at once. And we'll see this. I'm going to do a couple. It's going to join. It's going to try to do that named binding. And what we're going to see, what we should see, is this alias last appointment already exists. The binding is already in use. So that's a piece that, that can throw us. What it means then is that we either have to set it up once and guarantee that it's only used once, and then we can't ever call that join again inside of another query, or we can make use of a little bit of has named binding magic, which is a lot more fun. Because then what we can do is have as many of these as we want and just be as, not as careless as we want, but as carefree, perhaps, as we want. And then off we go. I'll show you what that looks like. Okay. So we're going to grab this with last appointment. The key here is this join, right? So we go if has named binding. Remember this, this last appointment here, this as, that's your named binding right there. The Ecto.Query docs set that up pretty nicely. If the queryable has the named binding, last appointment, we're just going to return the queryable. We don't need to rejoin it. We're already there. We're already a member. We don't need to rejoin. Otherwise, we do all of this nonsense. And then now what we should see is, I guess, a bunch of timex errors. That's odd. Those weren't happening this morning. But we'll see that it passes. What this means then is that I can call this with last appointment inside of other queries if I see fit. And then by calling it inside of other queries, I can compose things at an even higher level. Right now, the story that we're telling, this is Merrill's language actually from yesterday, it's like we're telling a story with these queries. Right now, the story that we're telling involves knowing that there is a join. But we don't have to know that to be, that's not a thing that we actually have to know for the story. That's an implementation detail yet. I'm going to leave it right now because there's not a compelling reason to change it, but we don't have to know this. And so the fun thing then is that we can now start composing things in even more exciting ways, which gets fun. Let's do one more for this query. We'll work this guy in. So all of these things, oops. No, I don't want to lowercase that. I want to yank it. All of these bits are the same, with the exception of we're grabbing this query. So instead of in query, it'll be something like by state code. Then we'll want to pass in our state code. That gets kind of fun. Let's do it. So go by state code. We're composing things together. We're making this into a pipeline. So again, we need to get our token first. I've called this queryable to indicate that it is a thing that can be queried, which I think is a Rails convention. Like when you're doing your polymorphic associations, it's like associable or schedulable or whatever. You could call it query. You could call it something else. It doesn't be consistent, and you'll probably be okay. Or spend a lot of time bike shedding as you see fit. There's nothing special about the name queryable. Feels like a thing that maybe is worth pointing out, but it's okay. So go from bison in queryable, like this initial from, I prefer to be the name of the resource. The thing that we're selecting from, whatever makes sense for you. We can join our query in association bison query, that's just an ecto association, where query.stateCode equals stateCode. And this will work, but again, it has the same problem with the named binding. In that if we try to join a bunch of times, we're going to override our, well, actually, this does not have the same problem as the named binding because we're not naming it. But we can go as query And then we can go from here. Save that. Should work. Nope. Line 92 is incomplete. Try this. Need a comma. It's always the comma. There we go. But again, if we do by state code, this is going to break. We've named our binding. Things are about to get weird. It's going to complain with this alias already existing. When you see the alias already existing in an Ecto.Query, it probably means that you're using a named binding more than once, or setting a named binding more than once. Not always, but probably. But we can do the exact same thing. Do something like with prairie. If has named binding, question mark, in our queryable, prairie, return the queryable if the binding already exists. Otherwise, go from bison in queryable, join prairie in association, bison prairie. Then means joy of joys. The way that we carry this forward is by modifying our from. So it's from the queryable along with any other named bindings we might care about. Then off we go. This should unknown bind name prairie. What was that? Yes. There you go. We won. All the tests are green. What a great day. The fun thing with being able to do things like this is that now we can tell stories. We can make our code composable. We can make it easier to work with these things, which is pretty exciting. There's one last refinement that I like. Note that at the start, we've got this bison. That's just the name of our Ecto schema. And remember that before, we indicated that we could select both from an Ecto schema or from an existing query. Sometimes we want to carry some defaults with us. Imagine like a soft delete, for example. You've got like a deleted at timestamp on a model or on a schema. If it's nil, still exists. If there's something there, we probably don't want to include it, and we're going to indicate to the user that their data is gone. It's not actually gone. It's soft gone. But we might want something like this. So we can do something here, like a base query. Again, in full chaos mode. Right now, it could be like from bison and bison, but it could be where is nil, bison.deleted at. I don't have a soft delete column. It could be something like this. We could have preloads that we want to carry with. Perhaps we want to bring the bison's primary veterinarian with. We could. If we want this every time, we can set this up as a base query. And the really cool thing about this is that if we have this set up as a base query, and if every single one of our little data access bits looks like this, where it starts with the base query and then continues through things that tell a story, that's a really consistent pattern. That's a thing that any developer can work with. A litmus test that I try for but do not always achieve is the notion that any line of code, any chunk of code should be readable by a moderately qualified intern or junior developer. They might not be able to mess with it. They might not be able to fully understand the implementation. But they should be able to tell by looking at the code, what is this thing mostly doing? With 80 or 90% accuracy. If we can do that all the way through a code base, really magical things happen. On the other hand, if we, and I've been in code bases like this, if we have these data, these reporting modules with 2,000 lines spread over 18 methods where each one is a subtle variation on the previous one, I don't know how you make sense of that without just sitting down and mapping it all out. I can do that because I have practice. I've practiced it. That's the only reason that I can do that, is I've had time to practice. Somebody who's fresh might not be able to, whether they're fresh to development as a whole or just fresh to that particular code base. Yeah, we can tell stories. We can make life a little bit more fun. We've got a couple of takeaways. One is that depending on the size of your module, depending on readability, you may choose to extract these into another module. If so, cool, do it, if that makes sense to you. If it's single purpose, if you're only using it here, leave it where it is, or don't. I mean, do what makes sense for your code base, pick a pattern, go with it, and that should work well. The other pieces that we can take away, again, with this composable Ecto.Queries, it is mostly useful in like a reporting layer and a data getting layer. It's not going to be super useful to you when you're writing data. It just won't be. That's okay. There are other techniques for those things. That's where change sets come in. But the big thing is, can we reduce the cognitive load? Can we make it easier to work with the code base? Can we make it easier to make sense of the code base? Can we make it easier to get in and say, yes, I know what this is doing? Rather than forcing someone to spend between 30 seconds and 30 hours tracing through who knows what. I've written code that has required that level of tracing through. I've regretted writing that code, but I've written that code. I'll probably write it again. But if we can make it so where someone can read through this in 10 or 15 seconds rather than 10 or 15 minutes, rather than 10 or 15 hours, life gets really cool. And then you have a very empowered development team, which then means that if they want to go and make changes, they can, by and large. Depending on the developer, they might need a little bit of help. That's okay. We work on teams for a reason. But they can at least say, this is where I am, this is where I need to be. If we reduce cognitive load, those things are possible. If not, we just give ourselves migraines, which is also exciting, but completely the wrong kind of exciting. The next touch point, nothing that I did here is novel. All of it comes from Ecto.Query. All of it is baked into Phoenix, or specifically into Ecto.Query, which we get in Phoenix most of the time for free. There's nothing novel. Anything that you can do in Ecto.Query, that is to say, from something in a thing that can be queried with a where, or a subquery, or a join, or a left join, or an aggregate function, or whatever you might need, all of those things come in. So mostly, like in writing this, it was a matter of reading through the Ecto.Query docs and trying things, occasionally coming up with some creative expletives, but mostly trying things until it worked the way that I wanted it to. The next bit. Joins are typically where composable queries start falling apart for most developers. As soon as you have joins, the first time you try a composable query, usually it falls apart. But with the named bindings, using as, and with the has named bindings, most of that trouble goes away. Not all of it, but most of it, which gets pretty cool. And then using a default query lets us get away with quite a few things in terms of records that are not yet soft deleted, records with the requisite preloads, records with joins that we already know we're going to want, records with other like where clauses or other filters. We can get away with a lot using that just by setting up a little bit of a default query. It works most of the time, for most cases, I should say. In the cases where it doesn't, that's okay. If you establish a pattern, deviations from the pattern make more sense and are more notable and are things that we can look at. That's it, I think, for the code that I'd like to talk about today. Thank you so much for being here. I hope that all your bison are shaggy.
Thanks, Andrew. Thank you very much. We're going to be taking questions. Give me a second. I need to get there.
I have like 2 questions. First of all, thank you for that. I really love that you did the live coding. It's always like, I know it can be scary, but I think you did awesome, so thank you.
Thank you.
And just thank you for sharing this code. This is how I want everyone to write their Phoenix apps and their Elixir apps, so I love that you're putting that out there. My first question is for the first touch point, the takeaway, you talked about how it reduces cognitive load and improves readability. I find that when you have an approach that does those things, it also improves testability. So I'm curious to hear, like, what are your approaches to testing these kind of query builders?
What a great question. Thank you.
Thanks. You're welcome.
Thank you. I meant to talk about that, then just like, didn't happen. So when testing these query builders, I can pull up the test. I'll just pull up test prairie veterinary. Oops. Okay, so when testing these things, I haven't had a ton of success testing the queries directly. What it usually feels like is I write the query and then I test that it is what I wrote. The place that I've had more success is setting up, this is a record that I expect to get back. This is a record that I expect not to get back. This is, if I'm ordering, these are a couple of records that I expect to get back in this order, which means that it's an integration test rather than a unit test. The composable queries are pure functions. They're deterministic. They require no setup or anything like that. But I've not yet found a way that I feel happy with in testing them like pure functions. It is almost always set up some data, ensure that I get it back, or that I don't get it back, as the case may be.
Yeah.
Which adds a little bit of overhead, but for the types of applications that we do at Launch Scout, which is mostly internal line of business tooling, it's not been prohibitive at all.
I mean, for whatever it's worth, that's probably how I would test it too, like testing that the outcome is what you would expect, and maybe like stringing those individual functions together in different combinations and kind of testing their output. So thank you for sharing that. My other question, can we go back to your code for a sec?
Go back to the what, I'm sorry?
Go back to your code for a sec, like the actual query module.
Absolutely.
Okay, so you've got your base query on 81. What I really love about this is that you can make each of these individual reducer functions even more powerful by defaulting that first argument to your base query, and then you can sort of use any of them in any combination, even as the first or standalone query. Is that something that you found useful?
Sometimes. It depends on the code base, and it depends on intent. And so the way that you would default that for anyone who's following along at home is just like this. Set a default value. You can do this. There's nothing wrong with this. It is at worst value neutral. Depending on, in terms of it being helpful, it mostly depends on how do I want that story to go and how do I want that to read.
Totally.
There are cases where we might have a couple of different bases that we're working from. Perhaps we want the bison versus we want the bison and their first, like the most recent and soonest upcoming appointments select merged in, or we might want them as an aggregate, or we might want them as something else. And so it is sometimes useful to set a single base, then modify it later, versus a couple of different bases. If I were pretty confident that there were only going to be one base, I would do exactly what you said, which is to set it as the default. Yeah. I just don't always have that confidence.
Yeah, that makes a ton of sense. I'm sorry, I have one last thing, and then I promise to relinquish the microphone. Your calls to repo.all, I feel like you may have put these here because otherwise you can't really demo the code. But would you keep those there long term? Is that like too much of a loaded question?
For example?
Yeah, like 86, 77.
Yeah, we could. So keeping them in long term, this is a context, and so ideally it's fetching.
I'm sorry, I missed that. Okay,
if it were a query module,
I totally misunderstood.
no, we're good. Yeah. If it were a query module, then I would probably create like a semantic grouping of queries, where it might be these 4 lines together, plus some other modifier,
Yeah.
feed that into a repo.all or a repo.get or whatever.
In that case, do you mind if I ask, could you talk a little bit more about why you would not keep that call to repo all in a query module and why you've chosen to put it in the context, which is where I feel like it absolutely belongs?
Yeah, absolutely.
Sorry.
So putting this into, So putting it into, so pulling this out into a query module, the idea with the query module is that it should just be a set of tools where the tools are all basically the same kind of thing. Where in this, like in a query module, for example, it would be functions that produce things that I can pass to repo, for example. Where then I can pass it to any of a number of repos. I can modify otherwise. And so with a query module, my expectation would be that it'd be pure functions, it'd be that functional core that Bruce and James talk about in their OTP book. And then inside the context, we take something from the functional core and then do the stateful thing with it. Does that answer your question? Okay. Yeah. Yep, that's exactly it. That's exactly it. And this is all, I mean, these are all things that other people have done before me and better and articulated better. But yes, that's exactly it.
Okay, let's give a warm applause to Andrew.
Thank you.
Thanks, everybody.
Thank you so much.